someone knows what they were doing.
Yeah.
Who did that?
We have a vinyl cutter in our school.
You do, and
Here,
you used,
actually.
obviously, you've got some skill in it.
Yeah.
You're applying vinyl and cutting vinyl, and vinyl's expensive to buy. Good work.
So what seems to work best if you guys just introduce yourself and tell us what your role is on the team and what you start.
We have I have an introduction, so.
Oh, please do.
Go ahead, please.
Hi, I'm Yash and this is MechaTech. We are a rookie team at Valley View. All of us joined FTC to learn about the engineering process. The process includes building a robot, doing programming, updating the engineering notebook, collaborating with other teams, and keeping track of the budget. We have 6 people on our team. I personally joined robotics because I wanted to also apply programming to a real physical thing. A specific problem that, I guess we can introduce ourselves first.
Just your presentation, you can continue your presentation on.
Okay.
Yeah, keep going.
One of the problems that we faced when building this robot was how to get the treads to drive up the churros on the mountain. To fix this, we took some rubber tubing and there's silicone tape wrapped around it, and they're zip tied to the treads so that they'll catch on the churros and push the robot over. And this is Mitch.
I didn't decide about the self-contained.
One of our mentors gave it to us.
Oh, did you? Very nice.
Hi, I'm Mitch. I joined robotics because I like to build stuff creatively and just build stuff in general. I'm considered the lead builder on the team. One thing that we all helped with was this arm design with the 80-20. It's able to slide up and down so we can grasp the pull-up bar. This pulley system right here pulls it up, but it won't pull up because of this, since this will force it down. Both of these pulleys are on the same motor. We sprocketed them on 2 different, like, tubes or whatever you call them, like right here in this area. And then another one of our designs was this 3-axis claw, which allows us to pick up debris and then also grasp the pull-up bar. And then eventually, once we've gotten enough power or geared our motors correctly, we'll be able to pull up our robot with this claw because of the fact that it locks and there's no way you can now open it because of this.
It locks.
Yeah, if this closes first, you can now never open this.
That's it. Okay, let's see how it goes. Sure, that's very interesting.
And
Is that
then-
something you knew beforehand? or-
Yeah, one of our hopefully future team members helped us, and then we put the tape in here so that we could pick up debris more easily. And then this is going to be what we hold our climbers on to dump them into the bins.
Mhm.
So yeah, that's really what
So, and I'm sorry, the objective of this is to,
we can pick up debris and grasp the pull-up bar and hopefully pull ourselves up once we've geared our motors properly.
so today it's not,
No, it can't pull itself up, but it can grasp the bar.
okay.
It's capable of grasping the bar, it just doesn't have enough power yet to pull itself up.
And it can also reliably put debris in the high zone due to time.
Really reliably.
So what happens when you're trying, does the motor just kind of stall?
Yeah, it just stalls. It doesn't have, the robot's pretty heavy, so it doesn't really have enough power to pick it up yet.
Okay, what would you do to
Well, what
resolve
we're
that?
thinking about is we're thinking about taking this motor off and like perhaps moving it here and then putting this size gear on this axle and then putting this gear on this motor and then hopefully that'll give us enough torque to pull up the robot. And then if that doesn't work, we were gonna take out this piece and put a second motor on it.
Okay.
Interesting.
All right.
And
So-
this is neat.
Yeah, my name's Nate, and I'm one of the builders on the team. And I joined robotics because I really like working with physical things and solving problems on them. So one of the problems I solved here was this arm and moving it when it's at an angle. So when we used to try to keep it at an angle, it would fall down because this claw is way too heavy. So what I decided we should do is put a worm gear in right here. And because the worm gear, its motion isn't reversible, so it only has a limited range of motion. It'll just stop right there. so wherever we have it at, it'll stay there. And then one of the other things that I saw that worked on was these trigger trippers. The triggers for the climbers are at different heights, so this can bend down and reach those different heights. So, yeah, here's Matthew, our budget and 3D printing guy.
Hi, I'm Matthew. I'm a builder, and I joined robotics because I really like building stuff. So I really want to make a robot. Yeah. So I'm mostly in charge of 3D printing and the budget. So
What pieces did you do?
right. So Nate came up with this idea of the triggers, and I designed them on Autodesk. It's an inventor. It's a Autodesk Inventor. It's a program where you can design objects and then 3D print them. So this I personally made on Autodesk. Then we have a website called Thingiverse, where we printed this battery holder and phone holder. So both these things are 3D printed. And we also found these things, these kind of like guides that keep our arm in place. We also printed this kind of like cable holder, also that keeps the cable in place so it doesn't pop out during the match. And we're not using them today because they broke all, but we have these sliders that help our robot, our arm slide up and down. I'm not sure if they mentioned this, but so I just kind of noticed this. This is really big on climbing the mountain, the elevated sprockets. I don't know if they talked about it.
That's right, yeah. Oh, yeah.
Oh, okay, maybe did. But yeah, without these, we wouldn't really be able to get up the mountain that easily. And as I said, also worked on the budget, which is it's a Google Docs.
You can have it right here.
And yeah, so.
So you must be good. It looks like you saved $1,000.
Yeah, and it's basically where we keep track of all.
Your spending.
Yeah, all our spending. This is, right here is everything we've ever spent. We have some, we have different charts.
What is yellow?
So yellow would be not reimbursable, so what we have spent and we cannot be reimbursed. Blue would be reimbursements, possible reimbursements from, I'm not sure if you could really call her a mentor, but somebody called Kit. And we don't have any greens at this moment, but green is what we have to reimburse.
Okay, well, interesting. Good
So I think
use
this
of
was printed a
everything.
while ago because we do have some stuff that's reimbursed. So.
Okay.
Yeah, and then here we keep all our receipts.
Oh.
Yeah, so that's where all our receipts are. And I think that's it for me. Right, so here's Ryan, and he's a programmer.
Yeah, I'm Ryan and I'm a programmer. I joined robotics because I liked building things and making them move.
Okay.
One of the problems I solved was our motors couldn't go at different speeds and we couldn't be precise. So the way I fixed it was I went into the programming and changed it so the harder you push on the joysticks, the faster the motors would move. And I did this for the two motors that turn the treads, the claw and the trigger trips. And then another thing I did was the autonomous programming and programming the controllers.
Did you get any help on that? Were you able to find some information?
Yeah, some people from,
One of our mentors.
yeah, one of our mentors, my dad, he's a programmer, and then Luke from Edina Terminators also helped us learn some programming.
Okay.
And then this is Noel, our media guy.
So I'm Noel, as you heard. I handle a lot of our media.
Okay.
I also do build though. I joined robotics because I enjoy engineering and I thought this was a perfect way to learn more. A few of the things that I personally designed was our logo and our name. So you also might have seen the trifold presentation.
No.
Yeah, that's in our pits.
Okay.
I created that too.
Okay.
It was originally for a Barnes & Noble fundraiser.
Is that in here?
Yeah, the maker
Yeah.
fair should be in there.
Yeah, the Maker Faire.
It's in one of the first couple tabs.
Okay.
And
So this is it. This is it. Control. Yes, I did.
so then my favorite thing about our robot that we all worked on a lot is the plexiglass and the vinyl. I contributed to this as a whole by cutting out some of the vinyl, drilling some of the holes in the plexiglass, and sticking a lot of the vinyl on. So thanks for your time. Once again, I'm Noel. This is MechaTech. Now, if you have any questions, we'll be happy to answer them.
So I wanna know what, overall, what you think, what you're most proud of with your robot or your team? Which one
I
thing?
think
The
the
arm.
treads and the arm.
The treads
and
arm.
Okay.
I would also probably say the claw.
Yeah, because at
Yeah.
first, we were the ones who came up with the idea of having the elevated sprocket, and we're an all newbie team, so nobody really
Yeah.
thought of it much at first, and then everybody's like, wow, these guys they're going
This
up the
really
mountain. Yeah, this
works.
really works. Guys are going up the mountain right away, so the 3 other teams at our school kind of stole the idea.
What led you to that?
That's what we came up with in the very beginning.
Yeah.
Once the first time we ever saw the video of the actual game, the whole team came up with the idea of the elevated sprocket so that the churro would get trapped under it and forced to go under the robot.
Okay.
First week, we just all sat down at a table and just started like doodling ideas.
Designs in the
Yeah.
notebook,
Yeah.
figuring out
Yeah.
how are we gonna climb the mountain, what are we gonna do for the arms,
'Cause at first we were set.
are we gonna push debris or not?
So at first we were like determined on going up the mountain, so, yeah, so this, like, that idea led us to think about the rockets, the elevators.
Our plan is kind of evolved on its way. So.
Yeah.
Okay.
Originally, we just had this to pull us up, and then along the way, as we were building it, we discovered many more uses for it. So.
And then this also helps with our speed on climbing the mountain. We geared our motors lower for more torque to get up the mountain easier.
One of the uses
Yeah,
that we
what kind
have.
of ratio you have? It looks like you have a 1 to.
I
Four
don't know
ratio?
off the top of my head,
I
but
think it's
So,
1 to 5.
It works. That's all I
it,
know.
it, it's hard from the Tetris box.
Yeah.
Is it your robot on right now? I guess we should shut it off.
Yeah, I do know.
There you go. So anyways, fingers get hurt. Okay.
You've got some very nice pictures here. You might want to include pictures from earlier design if you have any, to show how.
I have a notebook. I think I would have.
No, didn't we put those drawings in there now?
I thought we did. We had like pages full of just like.
It might be in the
drawings
very
of the
beginning.
robot.
It will probably be in the very beginning.
Okay, all I see is robot pictures.
And in the engineering process tab with notes from our meetings, here are some pictures from
Oh,
earlier.
okay. That's what I was looking for.
We also have a couple of design stories. I think it's the end, last month or so. Nate came up with a really cool one. Again, it was this one, and they're a really cool idea for the trigger trippers. It's really good.
This is our push bot.
That's from really early in the year. That was when we were going to Barnes and Noble.
Oh, okay.
We were trying to
That's our
learn,
track idea
learn
design.
what to do with the parts.
That's
Some of our
that's the
sketches.
claw.
Yeah.
That's
Oh.
like the claw alone.
Did you guys
That's
get,
very well like that.
did you give any thought how to protect your wiring at all? Looks like you're using some zip ties.
Yep.
All the wiring is actually under the
Size.
whole robot.
Yeah,
Oh,
it's like
okay.
that.
If I can.
Oh, yeah,
Excellent.
yeah.
Okay.
It's actually
And then-
good place something.
Hold on.
Okay.
Protect it.
What do you need?
Just once you flip it back up, I'll
Oh.
show them something.
Oh, okay.
Okay,
Thank you
so,
for showing us that. 'Cause I don't
I
know.
like that, yeah, that's very good.
yeah, so another way that we protect the wires is we 3D printed some of these parts. So that prevents it from wiggling around as much.
So that's a custom 3D print, that's
Yeah.
great, that's,
Yeah.
I don't know if other teams
Oh
have
yeah,
seen that.
I didn't mention that, but I didn't 3D print this, so I didn't really know how we got that in the first place.
That
Who
was
did
from
that?
Bucket Brigade.
Oh yeah.
One
That
of
was-
our,
Yeah.
one of the other teams.
That
gave it
actually
to
the
us.
hosting team gave that to us.
We also
Okay.
found out that.
Well, is that working pretty well?
Yeah.
Yeah, we're
Yeah, it
doing
works
well.
Yep.
really well. We also found out, I don't think, I think it was like last competition, our robot kept turning off, and I think we solved that. We just decided to take off the zip ties, because some of them were zip tied too tight or something. You know, it was
No, it was the
That
core
was
power
right.
distribution. Core power.
Oh yeah.
So it was the what?
I was
The
wrong.
core power, the early core power distribution modules had a failure in the box itself.
It
And
was a design flaw?
yeah, it was a design flaw by the actual engineers at High Tech Kids. The early core power, that was on the FTC forums. The early core power distribution modules had an issue inside of them where they would just intermittently stop controlling the robot,
Which was
and
really
you'd have to
frustrating.
restart the robot in the middle of competition.
Yeah, so we would just lose.
Connection.
Yeah, we would lose connection during the competition, which
It
was
was awful.
yeah, it was bad.
We actually lost competition.
We
lost
lost
final.
the-
We
Yeah,
lost,
we lost
we lost
connection.
the final
In the final,
We
because
lost
of that
connection
problem.
in the finals, and it was pretty.
and we
Oh.
didn't make it to state.
If we would have had a better core power distribution module, we would have gone to state.
Oh, really? Excellent.
We
So
were
did-
6
were
points
they-
behind, and our robot didn't move at all because
Did they send replacements then? Or did you have to
we
pay
had
them?
we had to buy another replacement. But we're thinking about sending a letter to whoever made the core power distribution module. I think it's
Just-
Modern
just
Robotics.
and making sure everybody knows that
Yeah,
that's
it's
a problem.
it's a huge problem.
I demand a refund.
And damages, of course.
Well, I'm sure having designed your own robot, you can understand that things don't always work out.
Yeah.
Do you talk about this from the bucket brigade? Is that described in your notebook there?
I don't believe so.
Yeah, because
Okay.
we only got it like a week or so ago.
Okay. Just I would recommend make sure you reference that in your notebook, saying, if somebody else provided, to acknowledge that from them.
Okay.
Thank
Oh,
you.
yeah.
So,
I'd also like to acknowledge Advanced Terminators, because they really helped us with 3D printing.
And programming.
I think they're here today.
They are
Yeah.
here.
Yeah, they are.
They're
Okay.
competing.
So we kind of helped each other out. They had some problems with
Design
their
issues
design issues,
and-
and they really greatly helped us with 3D printing
And programming.
and programming. Right now, 3D printer's broken, so that sucks.
One of the things that just jump in here for a moment. I like that you documented how the tread design was.
That actual picture was before we had
I
it.
understand.
It was like
I
a couple
understand.
days ago,
And,
actually.
Yeah, very recent, then you tried this,
And
you tried this, then you tried this. Oh, that's excellent. And it's very well documented, that you certainly have shown progression in making it custom.
thank you. I think you just became disconnected here. Didn't you? So there was
oh
like-
yeah. Oh,
disconnected.
oh yes. Thank you. Thank you for that.
Oh, thank you.
Thank you for pointing that out.
Yeah. I was wondering why it was so loose there.
Yeah. Thank you for pointing that out to us.
Maybe that.
That's why this thing was messed up.
Whose idea was this?
This
No,
idea?
not that,
The
the
sticker.
label.
Oh, that was we had to put that on during the
the
robot
tournament.
inspection.
Because when we initialized it, it moved and they had to put a warning so the
Yeah.
refs would
Yep.
know.
'Cause
You know,
it goes-
someone doesn't get smacked in the face
Yeah, it's a safety
when they
deal.
turn it on.
Yeah. How about the worm gear? I've not seen.
That's
Yeah, that's what I
Came up
did.
with it.
So,
Excellent.
Yeah.
How did you come up with the idea of using a one year?
well, I learned about it in design robotics 2 years ago,
Really?
and I just remembered that works really well. And this motion is reversed.
Nate actually solved like a lot of our problems. I don't think we'd be
Yeah.
here without him.
No,
so-
we wouldn't. We
We
wouldn't
wouldn't.
have been
We
here
wouldn't.
without them.
We've
Be here
been
without
trying
all you
like
guys
all
do.
these things like for days, and then Nate just comes along and goes,
We
"Hey, what if we do this?"
What if we do this? It's simple to the point, and
We were trying to
Solved a lot of problems.
zip tie
Okay,
these
so-
two
You need
a water
from
for
the top.
catfish.
What we were trying to do is we were trying to go around here with zip ties, and we couldn't figure out a way. And all of a sudden, I just decided we should
go through.
go right through here where the rubber things go. And it works really well.
So how important is field testing in the design process?
Very,
Very,
Yeah.
very
Yeah.
important.
I don't
We've-
think
Put the idea together, that's it, right?
We wouldn't.
Yeah,
We wouldn't know what to do without.
we
our
did a
field
lot of
testing.
field testing yesterday. A lot of field
our
testing.
last week
yesterday.
has pretty much been spent on just practicing.
We had a competition last Sunday,
breaking
and
stuff.
that yeah.
So
So we spent all this week
A practice
fixing. Yeah, no, a real competition.
Oh, you did back to back?
Yeah. The only time we could get in was these two competitions. They were all otherwise full.
Okay.
So we had to go back to back, and then we spent all this week trying to figure out how we were gonna climb the mountain better. Cause we could get up to mid-zone easily with just the tracks and
Yeah.
not these guys. Then we came up with the idea of using just this tape on the whole track, since it's all sticky. And we made it partially up. we got it like partially high, and then we figured out that we saw this from another robot in last competition.